Innovatech Company Limited is a cutting-edge technology company that specializes in developing innovative solutions for businesses of all sizes. We offer a wide range of services, from software development to cloud computing, and our team of experts are dedicated to helping our clients succeed. With our comprehensive suite of products and services, we can help you transform your business and take it to the next level.
Innovate with XYZ, connecting people to technology.
Hi, good day. I'm interested in grabbing your services for my project. Can you help me get started?
Hello. Good day too, Mr. Balmaceda. Sure, I'll be happy to help you. Can you tell me a bit more about your project and what you need from us?
Yes, I'm planning to launch a new mobile app and I need a team to help me with the development and design.
Great. Our project manager will be the best person to talk about your needs. Let me connect you with them. I had here project manager Mr. Galero. I will connect you to him now.
Hi, Mr. Balmaceda. I understand you're interested in our services for your mobile app project. Can you give me some more details about what you're looking for and any specific requirements you have?
Sure, I need a team with experience in mobile app and development and design. I also have a tight deadline, so I need to make sure the team can work quickly and efficiently.
Understood, and I will take note that, Mr. Balmaceda. So actually, we have a talented team with extensive experience in mobile app development and design. And we're very accustomed to working with the tight deadlines. So let me introduce to you to our team leader who can give you more information about how we can help you. So the team leader is actually Mr. Valenzuela.
Hi, Mr. Balmaceda. I'm the team lead for the design aspect of your project. We can provide you with a range of design options to choose from, and we'll work closely with you to ensure that the final product meets your vision and goals.
Hi, Mr. Balmaceda. I'm Mr. Cultivo, the team lead for development. We use agile methodology to develop your app, which means that we will be able to adapt quickly to any changes that arise during the process. Our goal is to deliver a high-quality product on time and within budget.
Oh, that sounds great! Thank you for your help. I feel confident that your team can help me achieve my goals for this project.
It's our pleasure. We're excited to get started and look forward to working with you.
Successful online meetings for XYZ Innovatech Company Limited and its important personnel were executed. Mr. Galero, the project manager of this project, was able to know all the estimated days that will be needed in each activity. All the materials and workforce that will be needed for developing an apps of Mr. Balmaceda have been prepared.
What is critical path diagram?
A critical path diagram is a visual representation of the tasks and activities required to complete a project. It is used to identify the sequence of tasks, the duration of each task, and any dependencies between tasks in the development of an app. This diagram can help app developers to understand the workflow of their project, identify potential problems and prioritize tasks to make the most efficient use of the available resources.
What is the critical path method in developing an app?
The critical path method, CPM, is a project management technique used to identify the sequence of activities that are critical to the completion of a project. In the context of developing an app, the critical path would be the sequence of tasks that are essential to delivering the app on time and within budget. To apply CPM to app development, you would first need to break down the project into smaller, more manageable tasks or activities. Each activity would then be assigned a duration and dependencies. Dependencies refer to the relationships between activities, where the completion of one activity may be dependent on the completion of another.
How is the critical path method applied in the field of developing apps?
The critical path method, CPM, is an essential tool used in project management. It is used to identify the tasks that need to be completed in order to complete a project and the order in which they must be completed. This method can be applied to the development of mobile applications. It can be used to identify the tasks that need to be completed and the order in which they must be completed in order to have a successful app launch.
Now let's proceed. The table shown is the activity schedule for our project. We need to construct the project network diagram, perform forward and backward passes, determine the project completion time, calculate the slack values and state the critical path. We will be using this node convention. A means activity, ES means the earliest start, F means the earliest finish, LS means the latest start and LF means the latest finish. Without extending the minimum completion time of the project, let's begin with a scratch to make it easier when drawing a network diagram. Activities A, B, and C have no predecessors, so they can begin a start. Activity D needs it to be completed before it can start. Activity E needs B to be completed before it can start. Activity F needs C to be finished before it can start. Also, G needs C. H needs both E and F to be finished before it can start. I need D. J depends on H and G. Since I and J have no successors, they go to finish.
Here is the network with activity nodes displaying letters and times. Let's do the forward pass. A has no predecessor, so its earliest start time will be 0. And since it has 6 weeks to be completed, its earliest finish time will be 0. Plus 6 is equal to 6. B has the earliest start time of 0 and with an activity time of 3, it will have the earliest finish time of 3. C also has no predecessor, so its earliest start time will be 0 and with an activity time of 4. So it will have the earliest finish time of 4. Now D needs be completed before it can start. Since the earliest finish time for a 6, then the earliest start for D is 6. And with an activity time of 2 weeks, D will have the earliest finish time of 2 plus 6 is equal to 8, he needs B to be completed before it can start. Since the earliest finish time for B is 3, so the earliest start for is 3, and with an activity time of 3, so he will have the earliest finish time of 3 plus 3 is equal to 6, F needs C to be completed before it can start. Since the earliest finish time for C is 4, so the earliest start for F is 4, and with an activity time of 5, so F will have the earliest finish time of 4 plus 5 is equal to 9. G needs C to be completed before it can start. Since the earliest finish time for C is 4, so the earliest start for G is 4, and with an activity time of 3, G will have the earliest finish time of 4 plus 3 is equal to 7. H, on the other hand, needs the F to finish before it can start. Since the earliest finish time for F is 9, which is higher than the earliest finish time of E is 6. So the earliest start for H is 9. Because in forward pass we need the highest of the earliest finish time. The earliest finish time of H will be 9, plus 5 is equal to 14. I needs D to be completed before it can start. Since the earliest finish time for D is 8, so the earliest start for I is 8, and with an activity time of 5, so I will have the earliest finish time of 8 plus 5, 5 is equal to 13. J needs G and H to finish before it can start. Since the earliest finish time of H is 14, which is higher than the earliest finish time of G, which is only 7. So the earliest start time for J will be 14, then the earliest finish time for J will be 14, plus 3 is equal to 17. Since both I and J have no successors, they can both go to finish, and since J has the highest earliest finish time, which is 17, the project's completion time is 17 weeks at the finish node. Now let's do the backward pass. Since the project completion time is 17 weeks, the latest finish times for the activities are the finished node I and J to be 17. That is, I and J cannot be completed in longer than 17 weeks. Next, we obtain the latest start times by subtracting the activity times from the latest finish times. For J, the latest start time will be 17. Minus expected time, 3 is equal to 14. For I that the latest finish time is 17 and the latest start time will be 17. Minus expected time, 5 is equal to 12. For H, the latest finish time is 14 and the latest start time will be 14. Minus expected time, 5 is equal to 9. Minus expected time, 5 is equal to 9. B 14. Minus expected time, 3 is equal to 11. For F, the latest finish time is 9 and the latest start time will be 9. Minus expected time, 5 is equal to 4. For 8, the latest finish time is 9 and the latest start time will be 9. Minus expected time, 3 is equal to 6. For D, the latest finish is 12 and the latest start time will be 12. Minus expected time 2 is equal to 10. Now C has two successors F and G. The latest start times are 4 and 11. So put, because when doing backward pass, the latest finish time of an activity must be the minimum of the latest start times of its successors. The latest start time for C will be minus 4 is equal to 0. B has only one successor. So the latest finish time will be 6 and the latest start time will be 6. Minus expected time 3 is equal to 3. For A, the latest finish time is 10 and the latest start time will be 10. Minus expected time 6 is equal to 4. The backward pass is now complete. Now slack for an activity is defined as how long the activity can be delayed without extending or increasing the project's completion. And it's calculated as its latest start minus earliest start or latest finish minus earliest finish. So the slack for A will be 4 minus 0 or 10 minus 6 will be for the slack for B will be 3, slack for C will be 0. Slack for D will be 4. Slack for A will be 3. Slack for F will be 0. Slack for G will be 7. Slack for H will be 0. Slack for I will be 4. Slack for J will be 0. Note, for example, that activity D can begin anytime between weeks 6 and 10 and it can finish anytime between weeks 8 and 12. This can be delayed for up to 4 weeks and the project will still be completed in week 17 weeks. On the other hand, activities C, F, H and J cannot be delayed at all without extending the project's completion time. Slacks are called critical activities. They form the critical path, which is the longest path in the network. So the critical path here is C, F, and J. The completion time can also be found by adding up to activity times for critical activities. That's all. Thank you.